In this particular video, we are talking about exponential and logarithmic stuff. All right, and this is something that we went over class, but also this is just something to kind of have a visual understanding of what was going on if you wasn't paying attention to in class. Now, before we begin, there's some things that we must address. Now, I put this little saying up because you guys got math all wrong. You think it's a copy and paste thing. Like, okay, I give you a problem, and then you practice. It's a similar practice. Is copy paste, and then on the test, you go copy paste. It's not like that, y'all, and it won't be like that. And I do apologize to the teachers who had teachers before me have done that to you, or you have not had a teacher. All right. Before I could allow you guys to go to Algebra 3 or pre-calculus, I need for all of you guys to step it up. You must understand what is mathematics. Mistakes allow thinking to happen. I know you guys want to get it done on the first try. You can't do that. It could never happen. There's not even one mathematician who gets on the first try. Even those who are mathematical talented, you know, you gotta, struggle through it. Just like life itself. You students think that life is just gonna come by in and out. No, you're gonna always be met with some type of challenge. So in this math class is the challenge. So at times in the math class, you're gonna want to pull your hair out. You may want to slam the book. You may want to cuss Mr. Howard out and say, "I hate you. You're the worst teacher of them all." That's fine. That's cool. Danny's fine out there in the third. But again, mathematics, just like how we people are used to suffering to get to what we want, it's just that you got to put in the work. So again, do not expect my quiz that you guys could be taking. It's gonna be exactly the same stuff, same thing that we did before. The concepts are gonna be the same, and you are responsible for grasping the concepts and getting the help when you need it. If you don't ask for it, I'm definitely not gonna do nothing for you. So again, closed lips do not get help. So you sitting there at night, think you got it, you don't. Please mess up on my quiz. Remember, this is the 9 weeks that if you mess up, you're gonna suffer big time. Some of you guys with these F's and these D's, if you don't have a 76 or above in the class, if you do the same stuff that you've been doing, you're gonna fail this course. You're gonna fail the quarter, then you're gonna fail my final, and that's gonna be the end of that. So again, I need for you to think for yourself. You guys know a thing or two about math, you just don't want to use it. But you're gonna be forced to or flunk out. And you're gonna be mad while doing it. And you're gonna get right. Even if come kicking, screaming, all this, that, and the third. All right. So guys, in the classroom, we talked about this definition about what exponential function, where the b is the base. And we said what b has to be a constant, a positive constant other than 1. B cannot equal 1. X is not any real number. So this definition is obviously important. So we know that 2 to the x, that's an exponential function because you plug in for x, you're going to get that shape you need. And if you guys are struggling through this, just go to decimals and type these functions in. 1 to the half power of x. And again, these two right here, they satisfy the definition that has been talked about. This one, it can't happen because if you was to put this in decimals, it's just going to be a constant, a straight line. -1 can't happen either because it's going to be a broken straight line. And we know for a fact that the domain won't be consistent, so we're going to have to, do some domain restriction of this. So again, if you struggle through this, go put in decimals so you can visually see. An exponential function always going to have a shape that looks like this, or if it decreases like this, or if it's a reflect like this. And I know it looks like I drew a rational function, but that's not the case. X to the power of 2, that is not a function. I mean, that is not an exponential function because that base ends up being 1, and we can't have the base being 1. So, again, we talked about this. All right, the logarithmic function. The log form is equivalent to this form here, which is called what? That's called the exponential form. All right. These are basic properties. So b to b equals 1. So guys, going back to your knowledge of exponents here for a second. Oh, I'm sorry. Ooh. So guys, getting back to this. Why is all this equals to 1? Well, simple. Because b to the first power equals just b. Anything to the power to itself is just 1. Remember, the logarithmic form is asking you what base all right, to what power gives you that number. So let me explain this further. Like, for example, we have 5 squared equals 25, right? So when I write this in log form, all I'm saying is log, the base is 5. So 5, 25 equals 2. So all I'm asking is, with the base of 5, I got 25. What is the exponent? What is the exponent that gives me 25? 5 to what power gives me 25? And you say 2. So in this case, you are pretty much just saying, what power, if I give them the base b, gives me back b? And you realize that that exponent is going to be 1. So that's where it comes from. And again, you're asking yourself when you're dealing with logarithmic function, if I have the base b, what power gives me b? And the answer to that is going to be 1. So anything to the first power is itself. So let's look here. The base b 1 equals 0. So if I was to write the exponential form, I would say b to the 0 power equals 1. Because we know for a fact that 5 to the 0 power is 1. Anything to the 0 power is always going to equal 1 no matter what. For the logarithmic inverse, this is pre-cal, so you don't have to worry about that. You will see that with Mr. Broussard when you see him. So when you see him, Broussard is going to future that for those who are going to pre-calculus. Those in Algebra 3, you may not see that. Okay, let's go through this. So we know that the characteristics of the exponential function, the domain is all real numbers, and we know because since the domain is all real numbers, there's no vertical asymptote. However, your range, careful how you write this. Remember, this R had to be distinguished for the all real number symbol, so you gotta make sure you write that real good. Your range is gonna be from 0 to infinity. So you got the domain, you got the range, and because I have a range, and because this has an asymptote, the asymptote is a horizontal because you're dealing with the y. And then the y-intercept is also going to be 0, 1, or y equals 1. Right. You guys, the logarithmic has these following characteristics. It will have a domain of 0 to infinity. So that means I will have a vertical asymptote to be 0 and x-intercept to be 1. All right. And know that my range, make sure you write this real good. You gotta be able to distinguish this between range. And unfortunately, I'm gonna have to be stickler. The range is draw your two lines like that and do it like that. So that's tell me that that's all real numbers. All right. All right. In class, we talked about these just a little bit. And I'm not going to do too much time on those because we know what's up. So this is your logarithmic form, and you're going to put an exponential form. So 11 to the power of 2 equals 121. All right? So the 11 was the base. This 2 was my exponent. The 121 was my answer. So number 2, you pretty much do the same thing. 9 to the power of 2 equals 81. Just like that. Please pay attention to your placement of it all. And here, this is exponential, so we're going to write in logarithmic form. So log with the base of 7, 49 equals 2. Do not forget, I'm asking you, the base of 7, what exponent with the base of 7 gives me 49? And that's 2. Log, so 12 to the second power is 144, so 12, 144 equals 2. Because again, I'm asking you for the base 12, what exponent gives me 144? And you would say 2. 12 times 12 is 144. And again, we won't go too far into the logarithmic stuff because in pre-calculus, you will see that. And you're going to see a little bit of what we're covering today also in pre-calculus. All right. Before I move on, there's just a few things I want to make sure that we fully understand. Because I know that the struggle will be real otherwise. But we don't do all that. So, I give you something that looks like this. 2 to the power of 3. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . x minus 8 equals 16. Are those bases the same? No. So what do you know about 16? You could break that down into what? 4 times 4. Okay, what do you know about 4 times 4? Well, we know that 4 could break down into 2 times 2, and then 2 and 2. How many 2's are that? 1, 2, 3, 4. 2 to the power of 4. All right? Now from there, I could rewrite everything and get it together. So 2 to the power of 4. All right, let's get ready and do this. Bases are the same, so now you could solve them. Oh, I'm tripping, y'all. Forgive me. That's not 24. That is just 4 right there. Now we could solve this. Plus 8, plus 8, that makes 12. Divide that by 3, x equals 4. Just like that. Well, that was easy. What if I had something a little challenging? Something that were the bases are not the same and I can't do nothing to make them the same. So why don't we not try it? Going off your paper that was on your paper, 10 to the x to the 120,000. Okay, so here's the problem with this. You can't break that down anywhere. So guess what you're gonna have to do? So the opposite of exponential is log, but this ln, this is called the natural log. Give me a second. Ooh, ooh, bless me. All right. So let's go ahead and use these logarithms. Because there are two types of logarithms that you're going to be using. One, you're going to be using the ln, which the good news, that's not for that case. The ln is not for us. But I'm going to do a problem with the ln too. But this, because this with the base of 10, you're going to use a log, just a regular log. The log is going to be the inverse. Ln is where you're going to deal with those bases that are not like 10, that are not powers of 10, like 10, 100, or 1,000, or someone like that. All right? So let's try it. So this problem here, you're going to take the natural log of, well, the regular log, because you got a base of 10. So when that happens, let's go ahead and do it. So this becomes log 10x. And remember what you do to one side, you're going to do to both sides. All right. Now we're looking pretty interesting. Because guess what? That log right here, this log 10, this log and this 10 cancels out. So you're left with x. And you're left with log of 12 120,000. Now, you could leave it like that if you want to. I actually would prefer you to leave it like that because this kind of problem is leaning more toward the pre-calculus. I do want you to see it because it does expose you to it. So yeah, I do want you to know how to work these kind of problems, and I will be uploading some Cahoots for you guys to practice. All right. So we did it with the log. All right. Now we gotta do the natural log. Again, the natural log is when you dealing with things that are not anything with a base of 10. So the natural log, going back to what you was doing, what we was doing in class, which makes it easy for us, we have 4x to the power of 15. How will we solve such a problem? To do that, you bring down the x for this. And this is the log naturel. Because that's what his real word is, log naturel. So that's just French for natural log. But that's how I was taught it. That's how you write it from there. And remember, you got to get x by itself. So to get x by itself, you divide both sides by ln of natural log of 4 over the natural log of 4. And x, when you simplify that, is ln of 15 over the ln of 4. Um, you could leave it like that, so you don't have to really calculate that, because again, this is tapping more of the pre-calculus. So if you just give me a nice little setup, I'll be all right with that. All right, we're gonna do one more problem. This is a problem that we was doing in class. In all our honesty, I don't want you to do it, but I know for a fact this is something that has to be done because of the purpose of factoring. So you must factor. So with a problem like that, remember how we wrote it as a factoring problem? So that E could be written as the following. So you could actually write that, and I could explain a thing too about the E if you want to hear it. So E in itself is, it's just another exponent. It's just saying exponent. However, the E, the Euler's E, is irrational. So, and that's also them on the pre-calculus topic. But again, gotta have that discussion because you gotta see it, know how to factor it, and when you take your ACT, you know, it's factoring, like I was saying, is in various forms of it. So you gotta factor. So let's do this. So you see how E is raised to the power of 2? I'll explain E a little bit further, but for the purpose, I want you to treat E as the following. I want you to treat E as an X. Don't worry about the X. Don't worry about the X's in the exponent. Just worry about what's there. So treat E as an X. So X to the power of 2 minus 4X plus 3. Again, these E's, you really want to treat them like an X. What, Mr. Howard? You tripping? Now, let me explain this. In class, I ain't gonna lie to you, I was a little bit off my game while I was dealing with this problem. Because it's like the thing that makes Algebra 2 a little challenge, because the concepts, you want to see them in pre-calculus. So it's like, okay, how far did I go into teaching teaching this. And these are one of those things that I do have to teach because you have to factor it. And factoring is pretty much Algebra 2 heavy base. And so when you get to pre-calculus, you got to be able to be a pro at it. So that's the reason why we are doing it. So again, treat all the e's like an x. Now you could factor. And I know in the class, I did this wrong somehow. And I was waiting to see did someone catch my hint yet. There's something I did wrong with that factoring. Yes, you're going to treat it like you are going to factor, but something I didn't do right to make that possible. Again, get it right, bonus points. So let's do it. Now we could factor, because again, we treat all the e's like an x. And the 2 right there, we treat it as x to the power 2. But we didn't worry about these x here. Don't worry about those. So let's factor. So we get x minus 3, x plus 1. That's how you properly factor that particular problem. Now, this is the part where you do got to go back to the e's. The reason why I say go back to the e's because you still got to use those natural logs. So this is going to be e. Well, I could erase this. E x minus 1. Oh my God, Miss Howell, you killing me. Or ex minus 3. All right. So again, you got to set these to 0 for each one of those. So this is going to be e x minus 1 equals 0. So you get e to the x equals 1. Now again, you take the natural log of this, ln, and you do that also for that because you don't have a base of 10. You got some irrational number, which is e. So guess what happens? That cancels out and that'd be x equals 1. And then here, x, e to the x minus 3 equals 0. So when you solve it, you get e to the x to the power of 3. And then you do natural log, cancel this out, x equals 3. And that's it. That's all you gotta do. No more, no less. I know that was hard because of the whole changing up the letters, but please do not give up because you saw something different. Please don't freak out. Because I know that's something, oh my God, you feel defeated and beat up, but don't do it. Because if you don't get overcome that, you ain't gonna never make it. All right. And again, when you get to pre-calculus, this is going to be expected of you to know. All right, let's proceed on. This problem, I'm not going to really do it for you because this is more of a written comprehension problem. Read the problems, put stuff in places, and be done with it. All right. So P is present. E is just that exponent, rate, and time. So I'm going to do it for you anyway. So 400, because that's what she have, and we try to figure out how much she will make, which is A, and that's going to be the future. E, 3%. Guys, you got to learn how to write percent correctly as a decimal form because you got to struggle with that. When y'all do 3%, y'all thinking that it's just 3%, but in the calculator, because percent is out of 100, you're going to have to put point 300 just like that. 0.03 is 300 times 8. In decimals, because you can put that in decimals and you could get an answer straight up. You just have to do it like this. 400 E 0.24. 24 hundredths. And that's all you have to do, y'all. Just that. And your problems, again, it's going to look a little, it's going to be different for this, but it's going to be the same concept. Put the places together and that's it. All right, y'all. I'm out. Done. I will be giving you some more practice to look at as you prepare for your quiz. So do that. And see too that you are actually doing the practice. I'm going to give you some paper practice problems for you to do. Please do them. Do not just do the Kahoot, but look at this too. All right, y'all. Bye bye.